Dickinsonia was a strange, segmented organism that lived during the Ediacaran period, some 550 million years ago. But just what kind of life form it was has been a mystery. Was it an animal, a fungus, a lichen, or even a completely different class of organism with no modern counterparts? A new British study offers substantial evidence that the creature was indeed an animal, and previous beliefs about how it grew have been flipped on their head. Fossils of Dickinsonia were first discovered in 1947, and initial assessments described it as something akin to a jellyfish. Since then, its identity has been debated, with the creature likened to a worm, Plecozoa, Biliterian, fungi and lichen, among other organisms. Dickinsonia belongs to the Ediacaran biota, a collection of mostly soft-bodied organisms that lived in the global oceans between roughly 580 and 540 million years ago, says René Hicksema, lead author of the new study. They are mysterious because despite there being around 200 different species, very few of them resemble any living or extinct organism, and therefore what they were and how they relate to modern organisms has been a long-standing paleontological mystery. To try to pin down Dickinsonia's place in the tree of life, researchers from the British Geological Survey and the universities of Cambridge, Oxford, and Bristol studied how each individual creature might have grown from youth to adulthood. They determined this by how many units or segments each specimen had, and figured out how old each unit was according to how far down the body it was. For the sake of being thorough, the team made two sets of data, with growth started from one end of the creature each time. The end result was a series of data curves plotting out the increasing length and number of units for each specimen as it grew. From there, the researchers were able to create a computer model for the development of the creature, which could then be used to test out existing hypotheses about how it grew and from which end. The units are wider at one end of Dickinsonia's body, believed to be the head, and get narrower and closer together towards the other end. The smaller segments were thought to be younger, therefore suggesting the creature grew from its posterior, but the new research conflicts with this. We were able to confirm that Dickinsonia grows by both adding and inflating discrete units to its body along its central axis, says Hicksema. But we also recognized that there is a switch in the rate of unit addition versus inflation at a certain point in its life cycle. All previous studies have assumed that it grew from the end where each unit is smallest and was therefore considered to be youngest. We tested this assumption and interpreted our data with growth assumed from both ends, eventually coming to the conclusion that people have been interpreting Dickinsonia as having grown at the wrong end for the past 70 years. By studying the development of the organism into adulthood, the research was able to confirm that Dickinsonia was an animal and not a fungi, lichen or any other form of life. When we combine this growth data with previously obtained information on how Dickinsonia moved, as well as some of its morphological features, we were able to reject all non-animal possibilities for its original biological affinity and show that it was an early animal, belonging to either the Plecozoa or the Eumetazoa, says Hicksema. This is one of the first times that a member of the Ediacaran biota has been identified as an animal on the basis of positive evidence. Since Dickinsonia predates the Cambrian explosion, the scientists are hopeful it can now take its rightful place as one of the earliest complex animals, and a key step towards common traits in modern animals, such as segmentation and having vertically symmetrical bodies. The research was published in the journal Proceedings of the Royal Society B.